Look at this stack of physical books and papers. When HTML was first created, its sole purpose was to mimic this exact structure digitally, formatting and organizing academic text documents for screens. This shows a standard desktop setup from the 1990s. Early web users interacted with sites that were completely static. You clicked a link, waited for the page to reload, and read the text. It was flat digital paper. Today, expectations are different. We demand interfaces that react instantly, fluid, interactive software that responds continuously to our inputs. Early developers tried to force this interactivity by writing heavy blocks of JavaScript to manipulate layout elements. Doing so bogged down browser performance, creating lagging, stuttering web pages. The modern solution is CSS. Built directly into the browser, it operates as a hardware-accelerated design engine that manipulates space and time to build interfaces without relying on complex, heavy scripts. We start in the first dimension with the raw materials of modern UI. Instead of downloading bulky image files, developers embed lightweight, scalable vector icons directly into the document using a simple script tag. The browser calculates a strict hierarchical document object model, processing layout commands top to bottom. Flexbox breaks this vertical stack, pulling the layout into the second dimension by projecting horizontal and vertical axes. Elements are mathematically centered and automatically wrap into new rows when screens shrink. The rigidity of standard document flow is gone. Flexbox operates as a complete two-dimensional space manager. The third dimension manipulates the physical geometry of an element itself, handled by the CSS transform property. This grid shows spatial translation. The transform property detaches an element, shifting it across X and Y axes using precise pixels or percentages. Beyond moving, it tilts the element by specific degrees, scales its proportions, and skews its geometric angles. Moving an object across a screen traditionally forces the browser to recalculate the entire page layout on every single frame. This causes heavy rendering lag, known as repaints. This image highlights a computer's motherboard, which routes data to the graphics card. When CSS executes a transform, it completely bypasses the main processor. The browser hands these specific spatial calculations directly to the GPU. By offloading the math, the browser guarantees smooth 60 frames per second rendering. Visual manipulation becomes totally separate from heavy structural layout calculations. This timeline introduces time. CSS keyframes establish a chronological sequence from 0 to 100%. By placing markers, developers scale elements or shift colors at exact moments. Timing curves dictate natural momentum, while custom Bezier curves plot specific velocities for unique bounce effects. By attaching these temporal keyframes to interactive triggers, like a user hovering their mouse over a box, static layouts instantly transform into kinetic experiences. Bring all these dimensions together, and you have lightweight vector assets mathematically locked into a fluid, responsive Flexbox grid. A cursor rests over an element, triggering hardware-accelerated keyframes to scale the icon, rotate it on the z-axis, and cast a dynamic colored shadow. CSS began as a simple styling tool to color text. By integrating layout math, GPU manipulation, and physics-based timelines, it functions as the definitive engineering system for the modern digital canvas.